Hi everyone. I'm glad to be here. Thanks, Harpreet, for the introductions. It's a pleasure to be here with all of you. I'm also excited actually to be here. Currently, it's 12 o'clock in Indonesia, so please bear with me. I'll try to do my best actually, but yeah, I'm just super excited basically just to speak in front of you all. All right, so I'll start basically by sharing my screen and to basically give some, yeah, let me share my screen. Cool. Yeah. So again, my name is Syafri. So I'm a VP of Data Science for Gojek. So today I'll actually bring you the stories about Gojek, how we have become a hyper growth startup, and how do we scale machine learning within Gojek itself, right? I'll start actually with a problem, right? So I don't know if not a lot of people know, but Jakarta used to be crowned as world's worst for traffic gridlock. That was actually in 2015. And there were actually a lot of challenges, right? If you look at Jakarta, it's a very busy city. And the best way to actually move from one place to another place is actually via motorcycles, right? And then this presents opportunities for some of the informal workers. So they call themselves Ojek, actually. So that's how we call them. So these Ojek drivers, what they typically do, they offer a service to bring a person from one place to another place using a motorcycle. And then that person, one of those people actually who have used the services pretty extensively is our co-founder, Nadiem Makarim, who now have become has become the Minister of Education of Indonesia, actually, right? And then back then, he realized that there's actually such a huge opportunity. If you look at the size of informal sector in Indonesia, it actually comprises around 60 to 70% of the labor force. That was based in 2010, actually. So it actually presents a very huge opportunity, right? And then when we think about it, that once we're able to build the layer of trust to these Ojek drivers, not only that they can mobilize humans, but actually um, one can also ask why can't they, for example, bring valuable goods or even foods actually from one place to another place, right? So this is the problem that we try to solve. We try to basically remove the structural inefficiencies in the system using technology, right? And this is a very important problem to solve because especially like this is like such a big chunk of a community, and actually if we're able to empower them, it can actually reduce the daily frictions of people in Indonesia. Um, it all started in 2010. Gojek started as a call center, but since then actually we've grown pretty fast, right? So from 2010 to 2015, you can actually saw Gojek as a call center. Not until 2015 we started to create an app, right? And since then there was like a massive growth, right? In 2000, only within 1.5 years, so we became the first in the unicorn in Indonesia, and then we also expanded to different countries in Southeast Asia. And then since we became a unicorn in 2016, 2017, so only in a matter of like 2.5 years to 3 years, we became the first decacorn in Indonesia. So it has been quite an amazing journey back then, like how we started with a very simple call center, and then we became really like a super app where you can basically find all of your daily needs over there, right? And then when you see about it, there's actually so many icons. So each icon actually represents different services that we have, starting from food delivery, logistics, GoMart, on-demand massage, and so on and so forth. Yeah, so it has evolved since then, and then yeah, Gojek has become a verb actually to hack daily needs. So in fact, 1 out of 4 people in Indonesia um, has Gojek installed basically in their phone. So it's actually growing pretty big. In terms of impact, so these are basically the Ojek drivers, right? So in terms of impact, if you look at the total income contributed by driver partners itself, it amounts to 560 million US dollar per year, actually. And then for this SME partners, so these are all of the merchant moms and pop stores that we have. it amounts to 106 million US dollar per year. So it's actually pretty massive in terms of impact itself. And in terms of presence, right? So we are present currently in 27 cities in Southeast Asia. If you look at the stat of combinations of the driver partners and service provider, so basically it's amounted to 2.5 billion, right? It's almost like 1% of Indonesian population actually. If you think it away, almost this 1% of Indonesian population actually depends on the day-to-day life in our platform, right? So that also makes the work enjoyable, because actually, like, every time we make a mistake, right, you basically, your family, your friends will be able to feel the impact immediately. So that's the reason why, yeah, especially for data scientists, you'll see later on, we need to be very careful in the way we do our job, right? So I'm just going to flash this very quickly. So basically, I just want to say that if you look at the investors as well, some are very, very known. So we have a very strong backers as well for the company. And yeah, so I'll go to the meaty part after this. So given the hyper growth nature of the company, right? So one would ask, how do we scale the businesses, right? And why it is such an important question? Because as you know, we can't just add more and more people to the business, especially when the business itself grows exponentially. We can only, if you look at basically the like a simple economic graph over here, we can only add people actually in linear fashion. While if you have a exponentially growth business, at some certain point, there is actually like a breaking point, right? So we need to think of like a different ways to scale the business itself. And we are very obsessed with automation. We think that that's actually the only way for the size of like a company with our growth could actually scale very well, because without automation, it's just impossible, right? Imagine, for example, having 10,000 drivers in this case, and we have a call center that needs to assign the order one by one. Compare that with, for example, if we have the size of like 100,000 drivers, for example, right? It's going to be very difficult to manage if we only rely on manual assignments in this case. Just to give you some illustrations of what I meant by that, I'm going to tell you stories about our allocation engine, how it all started. Then you will be able to see how we started from our businesses actually using manual allocations to machine learning based allocation. So this is an interesting one, right? So if you look at the graph now, so you actually are able to see Gobis. This is the first manual dispatch. This is basically the screen that our cal operators actually see, right? And what happens is that every time a customer wants to order a ride, so they actually need to call the operator, and the operator actually needs to call drivers one by one, which takes a very, very long time, right? At some certain instance, it could actually take up to 2 to 3 hours for driver to come and to pick you up, right? It's a very inefficient. And then actually not until in 2016, we created a mobile app in order to do the matching, right? So this is how it works pretty much, right? So typically, like at the very beginning, a customer will call call operators, and then call operators will typically assign a certain customer to the nearest driver. It's a very naive allocation. So this is just to give an illustrations over here. So actually, if you look at the right side, this is the original code, which was written in Clojure back then. If you look at the algorithm, the first algorithm is actually a very naive allocation. So it's just basically will allocate each order to the closest drivers in this case, right? But of course, we know that it might not always be the most optimal way to allocate an order. Just take an example over here. If I look at the acceptance rate of drivers A and driver B in this case, although driver B is closer to the customer, but it can be that the acceptance rate is like only 15%, right? So out of 100 orders, he or she would only accept 15 of them. While if you look at driver A, although driver A is actually has a longer distance from the customer, but he or she always accepts the order. right? So we want to take that into account. So what you will see is that there will be like a change in the way we strategize the business, right? From optimizing for consumer experience into optimizing the completed order. If you see, for example, in the code over here, then you will see that we, uh, back then, we basically started to filter out all drivers acceptance rate less than 20% in this case. And then we do again, the allocations, right? But then we started to think, what if we want to incorporate more and more factors? Then that way of allocation will not be very scalable anymore, right? Because if you think about it, maybe there are many factors that you want to incorporate in your allocation engine. Not only you want to basically take into account the distance, acceptance rate, but maybe you want to take into account the rating. Maybe you want to take into account the quality of certain drivers. Or maybe you want to take into account the traffic situations at a particular area, right? So we think about it and say, hey, okay, that's a lot of if else statements actually to maintain, and it's not very robust, right? It's very difficult to debug, and there are just so many disadvantages actually of maintaining such ways. And then we start to think about like, hey, can we basically transform this into mathematical problem, right? And just for simplifications, imagine just for you to imagine it very like in a very easy way. Imagine there is like a sorting score where we basically sort drivers, right, based on certain factor, and corresponding to each of these factors, there's actually some weightage, right? So that's basically yeah, like a different way to do the allocations in this case. And then if you visualize it mathematically, we can actually encode decision making or business strategy in factors, right? So just to give you illustrations, for example, if we want to if we want to emphasize on customer experience, it means that distance in this case, right, will have higher weightage. While if you want to optimize for completed orders, then you actually give your acceptance rates higher weightage compared to the other factors over here. So what happened next is that we built allocation engine called Jeger. So Jeger objective optimization engine over here. So it comprises different like a feature store. There was some integrated experimentation surface inside, and it's actually able to do ensemble or different models that actually optimize for different business objectives that you want, right? Which allows the business really to choose the different configurations according to the what they wish at a particular week or month, for example. So in 2019, of course, this was actually pre-COVID. So Jeger actually has brought us 100 million incremental transactions. So yes, it's not bad. And then, yeah, this is also like a quote from our co-founder. So Jeger is really like an internal platform that can bend allocations in every directions, right? And the flexibility is really crucial, right? Because especially in a volatile market like in Indonesia, business wants to adopt the strategy very rapidly. If you, for example, imagine it like in a manual ways, if I want to change my strategy, I need to gather all the call operators over there, like brief them, and then I need to ensure that there are reproducibility and repetibility as well. And it takes a lot of time. And then we went to programmatic ways of doing things, like when we do that, a lot of like a if-else statement. But this is also not very scalable. And the reason for that is because typically we need to wait for we need to follow like a sprint cycle of engineering. Like we can only change it to 3 weeks basically. So it also takes a lot of time and it's very difficult to maintain. And then we shift to the different ways of doing business, right? So we want to do business in algorithmic ways. So what happens now with Jeger, for example, is that there is a kind of like a business portal where the business can actually just fill the configuration, right? Suppose that for Jakarta, I want to optimize for 75% customer experience and 25% completed orders, for example. Then the business just put it in this business portal, press a button, right? The machine learning models will be trained in the evening, and tomorrow it gets deployed without changing any single line of engineering code base. And that we believe to be the most scalable ways to kind of like run businesses, right? Because this gives the ability for the business just to really focus on the basically strategizing the business and how kind of like objective metric that they want to optimize, and then let the machine learning and algorithm basically do the rest, right? Let me do some time check a little bit. All right, cool. So yeah, so that's the kind of like grand visions of things, right? So let me basically go like a little bit deeper into the explanation, just to give you an idea, right? So machine learning is really at the heart of the business automation, right? And as a company, we are very obsessed with automations, right? We, as much as possible, we want to automate everything, because we believe that by automations and technology, we can really like scale the business really fast, especially given the kind of the market situations in Indonesia where things just moving very fast. So these are some of the use cases at Gojek of machine learning, right? So we use machine learning basically to improve the user delight and growth. That's number one. We use it also to basically keep the trust and safety of the platform. And number three, which I think also very actually important, is to create asymmetric values for our customers, right? So if you look at it, it's quite a wide spectrum of use cases where we use machine learning in this case. Maybe let me see if I want to kind of like mention a couple of things. Yeah, for example, in asymmetric values, we don't. I don't actually include it here, but we have, for example, a machine learning system which manages 80% of vouchering budget, right? So we want to be able to allocate vouchers also in the most optimal ways. And again, for all of the machine learning systems that we have, we try to make it multi-objective, right? What that means actually, like if you think about it from mathematical perspective, typically when you have two objective functions and you put it under one cost functions in this case, they'll kind of like cannibalize each other's, right? And what we really want is that we want to be able to optimize a multiple objective without actually cannibalizing each other. So, right? So there was actually like a technique in operation research called Gore programming that actually can be employed to do to do so. Yeah, so these are some of the use cases. We're gonna go like to some of them in more details, right? While also keeping it very high level. All right, so this is an example of how we use combinations of clustering and NLP actually to auto-generate pickup points within our app, right? So what we do is that we take the different points, basically where drivers and customers typically agree to meet, right? Back then, before these features exist, if you look at basically on the left graph, right, the locations can be very well, not really random in some sense, but it's kind of like scattered all over the place, right? But in these different places, you can actually find the centroid of the pickup locations. So it's actually very easy to identify the middle point of that, right? And then what we do, we run through millions of chat logs between drivers and customers, and using the language model, we'll actually be able to assign to each of these centroid the labels actually that gives the highest probability, right, of that occur. We assign that in automated ways, as such that currently, like we have around 100K pickup points which are being manually labeled by the algorithm itself. Yeah, so and actually it has improved basically the discoverability of the app itself. It used to be basically there's like 36%. If you look at basically the number of calls that happens between driver and customers, it used to be like 2 times between like a crowded locations, like shopping malls and etc. versus other locations, right? So you can actually take a conclusions that there are actually like a lot of confusions before these features are being rolled to the customers actually. Another example is the GoFood recommendations. So in these GoFood recommendations, we use embeddings in order to kind of like map different foods into a certain vector space. And then basically we use the similarity of these different foods to give recommendations to our users, right? And then actually the impact's also pretty big. So we got like a 20-30% higher conversion rate with this algorithm. Another example is demand prediction. So basically what happens over here is that we want to be able to systematically tell our drivers where they need to go. Um, and real-time map doesn't really work, right? Especially in places like Jakarta, when you tell them basically to go to certain areas, um, they will be stuck in the traffic for maybe 20, 30 minutes, right? So it can't be real time. And then because when they arrive at this point, right, maybe the demand basically has decreased. So what we need to give them is that we need to kind of like give them a smarter ways to map out, hey, where will be the peak in demand, using like by combining different signals, basically from supply, demand, traffic, weather, clicks, for example, and then be able to summarize that and give them like a predicted demand in some certain region, right? This way they can actually plan their trip, especially around Jakarta. This as an example, or basically in any crowded cities, right? Yeah, so that's how we use it in demand prediction. Now allow me to go a little bit into machine learning systems at Gojek. So how do we basically, the next question will be like, how do we scale all of these different machine learning for like different use cases that our users have? Um, yeah, so this is actually like a very interesting graph, right? So on the left side, you have an expectations of what a machine learning system, right? It's probably like up to now, people sometimes think that it's like so beautiful, all shiny, right? But in the reality, they're actually like much more than modeling that one needs to take care in productionizing a machine learning system, right? I would even say like probably only 10 to 15%. And for the rest, there's a lot of actually like a non-modeling things, right? Starting from surfing, validation of features, for example, routing, experimentation system, even all the way up to the meta stuff, like how different teams, right, like product engineering and typically data scientists and machine learning engineers, how they actually how do they work with each other, right? What is the best kind of like a sprint mechanism, for example? That's typically like the different problems that one need to deal with when basically working with machine learning a system in this case, right? Yeah, so what are the characteristics of the machine learning systems at Gojek that we want to aim? First of all, it needs to be very easy to experiment, right? And the reason why experimentation is important because this way we can also quantify the impact of a certain approach, algorithmic approach of choice. And it actually allows us also to do a very fast iteration. At Gojek, we try to look at experiment from four different ways, right? So we need to be able to do A/B testing. The fact that there are so many network effect and spillover effect in our experimentations, we need to think about switchback experiment as well. And for the type of experimentations where you have the relationship between interventions and output, we need different type of experimentation. So we need a causal type of experimentation because then it actually allows us to understand what is the causal impact of a certain treatment. Because if you know, of course, like machine learning, most of the machine learning algorithms are really based on correlation, right? And then there's in some cases it might be sufficient, but in other cases we need a different type of models actually, right? Which is the causal model. We also have multi-arm bandit optimizations, and these are the type of optimizations that can actually learn and optimize exploration versus exploitations actually at each point in time. The next thing is about how the model iterations and deployment, right? So what we do at Gojek, we try to basically also shift from monolith to microservices, or basically in general, right? We try to decouple like one big problem into smaller chunk, and then for each of these smaller chunk, we build team around it, and we try to identify who will be the best owner for this if each of these chunk, right? And I think the advantage of this is because for each of these component, the team can actually move at their own pace, right? And then the only thing that they need to do once they finish the certain components, they can actually integrate with other components or with other teams actually using API or like a software contract. This also has proven to be efficient in terms of like iterating the machine learning systems that we created at that we have created at Gojek. All right, as you see over here, there's like a raw data processing, feature store, model trainings, and etc. So we try to decouple them and then give them actually the right owner, right? So data scientists in this case will focus mainly in training the models, feature storage, and the model store. Yeah. All right, and the next is easy evaluation. So it needs to be very easy to evaluate performance of the features and the models itself. It needs to be easy to search, and then we want to evaluate so we can iterate again to the models, right? And then the last but not least is the capability of scaling the models actually, right? If you think about it, Gojek itself is the philosophy that we adopt is that we want to localize a lot of things. Like if you look at Indonesia, right, or Southeast Asian region in general, they're actually very localized. So what that means is that we, instead of like making one big global model for everything, what we want to do is that we want to try to customize the model itself to the local market, right? Because there are just different behavior that we have observed from the data. But consequently, what that means is that the number of models that we need to deploy can be very, very big, right? So there needs to be capability to scale these models actually in a very easy manner, right? So that's what we do. Okay. Yeah, so the other things that we do is that we try to build a lot of the data science tools. This allows data scientists at Gojek to also go full stack, all right? Because by having these tools, they can actually focus on the things that they're good at, like developing model, right? If you look at some of the examples of tools that we have developed internally, we have a FIS. It's actually open source, so you can actually search for it. It's a feature storage. We also have a tools called Clockwork. This is basically for machine learning scheduling and automation, right? So typically, we do the feature ingestions also via Clockwork. And the nicest thing about having a feature storage or uniform feature storage, because then you basically deal with the asymmetries of features that you use when you train the models and the features that you use to do the surfing, right? And then it also allows a collaborative work because, for example, if one team creates features, another team actually can make use of that features, right? Another tools that we develop, right, which I can actually vouch for this tool because it has been very helpful, is Merlin, right? So Merlin is basically a model surfing tool. So what it does is that you can actually save the binary files into certain locations, and then like using some kind of like a wrapper, you can actually call Merlin, and then this binary file will automatically get deployed in Kubernetes clusters, together with some monitoring, logging features, and even there were some kind of like a drift detection as well incorporated inside. So you actually see if there are any changes in the distribution of your features, right, in the model, right? And the last we have Turing. This is sort of like a model router, which allows us basically to do routing or different experimentations, and it allows us also to ensemble different models, right, to kind of like again like doing some multi-objective optimizations in this case, right? Yeah, and I would really recommend all of you to go to our Gojek engineering blog. Then where you see like a couple of like different tools that we have actually used at Gojek, right? Let me check again the time. All right. Yeah. So lastly, what I want to say is that building scalable machine learning system is a journey on itself. Even for us, actually, it took us a lot of trial and error. I think the first machine, like a big success, machine like a big machine learning systems that we actually built, it took us maybe like one to 1.5 years just to be able to learn what will be the good design pattern for us to be able to make it integrable to product engineering system. But yeah, I think we are very lucky to have a very strong supporter from executive who are really patient actually to kind of like wait until the results materialize. It's not very easy to kind of like give the paid for data scientists actually, especially when you look at the number of, when you look at the amount of budget that we manage, for example, via machine learning system, yeah, it takes a lot of faith, right? So definitely one of the key ingredients as well for a success in creating scalable machine learning system is to have a very good sponsor from executives, because only by then you actually have the time that you need to really like try out, right, like different things, because definitely there are things that work, there are things that didn't work as well, and there's definitely like no silver bullet. It really depends on the company itself. It really depends also on your engineering architecture in terms of what is the best way to basically incept intelligence layer into the system, right? So yeah, it's a journey again. So yeah, especially for all of you who just started, I say it's definitely a very how do you call it? Although it's very difficult, but it's definitely very satisfying, especially when all these different pieces fall into places, right? So yeah, that's all I think my presentation. So let me see if we can actually get some Q&As.
Syafri, my friend, that was a awesome presentation. Thank you so much. I've been actually following Gojek for a few years now, so it's a great honor to be able to speak with you. Hey, look, if you're ever expanding into the North American markets, get in touch with me. But yeah, I really enjoyed that presentation. There's some interesting points in there that I think would be worth discussing, just so people kind of have an idea of some new things that they can go learn about. One of them was the switchback experiments.
Yeah.
Talk to us a little bit about those and how those work.
Yeah, so switchback experiment is actually very, maybe let me even start actually before that, right? So the fact that typically for ride hailing, and I can imagine also for some different type of industries, right? You have a lot of like a spillover effect or network effect, right? And what that means is that basically when you run when you apply some, for example, if I want to test two different matching algorithm, right? So what happens is that my one experiment will actually influence the outcome of other experimentation as well. So we can't always like test them simultaneously. So what we need to do is, also what we need to think is that actually how can we create a certain randomization unit to ensure that these multiple experiments do not interfere with each other, right? So switchback basically just like when you do randomizations actually via like maybe just the easiest way to kind of like visualize this is that you randomize it using geospatial and temporal as a randomization unit, right? As such that basically the different experiments like will not interact with each other, right? Yeah, the switcher basically you kind of like for example, if I have two experiments, so it can be like my experiment, let's call it AB. So you can actually do AAAB or BAAB, right? So in a very random fashion as well. And then you can use like the result of that just to measure the difference between them, right? I hope I can make myself clear. Feel free to dig a little bit
definitely.
deeper.
So yeah. coming from like a design of experiments type of framework, that would be similar to maybe the crossover design. Is that what that would be similar to?
Yes, correct. A little bit, yeah.
So yeah, that's really fascinating. I encourage everybody to pick up a design of experiments textbooks. There's so many different ways to set up experiments.
Exactly.
And I mean, you guys are doing heavy duty experiments there, man. What were some of the challenges before adopting a platform like MLflow to run your experiments? What was that like at Gojek?
Yeah, so I think that if I were to kind of like bring it a little bit to the meta level, right? So I think one of the challenges as well is really to educate the company of the importance of experiments, right? And really like the first questions that we always ask our product managers before they come ask it like I do some magic with machine learning, right? So they really come to us, and especially like yeah, like sometimes it's also actually like just funny to remember that yeah, typically people think that we can do everything with machine learning, basically that they can just do some magic, right? But again, like what we typically ask them before we create solution for them is that we ask them first, are there any experimentations actually capabilities within your product, right? just like a simple routing, for example, where you can just like split traffic, and for us to be able to kind of like incept intelligence over there. And not until a couple of years ago, we basically defy all of those different approach and create a like a generic experimentation platform, right? So we have a what's so called Litmus now. So Litmus is basically like a generic. You can think of it as a storage of like a, that actually store different configurations, right? And then nowadays, if a product engineers, if they want to develop some certain features, they need to kind of attach it to Litmus. So we can actually do some like a traffic splitting and be able to kind of like test it, right? So that would be the first one, I think, as the first challenge. And the second challenge, definitely, it's really like how to make sure that there are no cross contaminations and experimentation. The fact that we run thousands of experiments in a day, right? Just yeah, it's just like becomes a extra hard problem to solve as well. In terms of how do we do the randomization unit, how do we ensure that there's a control group which are not contaminated by experimentation. So it's definitely like a challenging problem, right? So I would call those are the two of my biggest challenge that are biggest challenge in the company.
Leads me to my next question here, talking about causal ML. Can just for people out there who like me are not too familiar with causal ML, can you talk to us about how that is different from just regular old machine learning?
Yes. I'm happy, actually. I'm glad that you asked about this question, but because actually this is a very exciting one, right? So again, like I mentioned earlier, is that a lot of machine learnings are based on correlation, right? So basically, what is the probability you observe X when you observe Y? If you look at, for example, within domain of marketing, right, or just like a simple, like a, for example, I want to give a certain vouchers, right? Basically, you wanted to know that whether that certain vouchers or certain treatments that to give to a customer actually has an effect to the output metric that you want. So it's not necessarily like a correlation, right? Because things can actually occur at the same time, but might not necessarily causing kind of like have a causal relationship with each other, right? So by building a causal model, you then wanted to know basically like what is given a certain. So you have a covariate matrix, and you wanted to know, like, given a certain treatment, what will be the average treatment effect of a certain treatments, and then you can actually use that in order to determine what is the best covariates that can explain this average treatment effect, right? So in a way, so there's actually another dimension. So when you deal with the typical machine learning, you only have basically set of covariates and output, but causal machine learning, you have the third dimension, which is the treatment, right? Treatment, no treatment. So they're like actually like a three different things that, of course, it's an oversimplification, but just to kind of like visualize it really nicely, then you have like a three components that you need to kind of like play around with, right?
Yeah, that's really fascinating, man. So do you have any like resources that you like use to learn more about this that you want to share with us that we can go and check out?
Yeah. So definitely, I would recommend Judy April book about what if. That's like a good one that I use. But yeah, I think like currently also, like, there are so many resources. I think like if people type causal ML, I also see that there is an increase popularity, actually. So Microsoft have a very good has a very good libraries, actually. So I would recommend to check DuI, EconML. So number one is DuI, EconML, and the third one, yeah, I forgot the number of the term. There are actually like a three big one, but definitely like the two ones will cover like most of the use cases that you would have in causal ML.
That first one you mentioned, that was Judea Pearl's book, What If?
Yes.
Okay.
Correct.
Yeah, he's also got the book of Why. Have you read that one yet?
Yes. That's actually probably what I refer to, the book of Why.
Okay.
Yeah, exactly. Yeah.
I've got the co-author of that book coming onto my podcast next
wow.
month, so looking forward to that. All right, so I could ask you questions, man, all day long, because that was such a fascinating presentation. But let's get into some of the questions from the audience. So Vasa Reddy wants to know, are there any preferred routes using something like k-nearest neighbors logic for those routes that you're talking about?
Yeah, what kind of routes exactly that's
That's a good question. I think it was talking about you're doing some type of clustering on the map to find
yeah,
people, location spots to meet up. So I guess
yeah.
Vasredi is probably curious, like, how are you doing those clusterings to get those routes set up?
Yeah, so it's actually not the route. So if I like, if you look back again to my examples of, I think this is related to the frequent points of interest, right? So really like finding like what is the? It's kind of like we want to generate the pickup like uh, frequent point of interest basically for the app. And it's just a simple like k-mean clusterings actually, just to because we basically just really need the centroid, so it's not really like a route, right? For the route itself, we also have a cartography team that develops like a route like a routing mapping actually for us. But in this case, we don't use any routing thing, right? So there is also like another things maybe I don't know whether that's what the question meant, which was about the problem about our logistic, right? So in the logistic, we basically use a lot of vehicle routing problem techniques, because I think if you look at the challenge over there, right, and let me try to illustrate the challenge a little bit. So really the metrics that we want to optimize when we want to kind of like send like a different packages from one place to another place will be to can we actually we batch the orders itself, right? And the tricky thing about it is that it's not really like to be kind of like um, a movement. So basically, what we want to do is that we want to be able to because, for example, one driver can carry multiple package, right? So it can be, for example, that they do first pickup and then they do drops and then drops again, or like multiple pickups. So what we do over there is that we batch the order itself, and we use genetic algorithm type of actually to kind of that's just like one way actually. So we try different things, right? So genetic algorithm is just one way. We also tried grasshopper algorithm in order to do that. As such that we are able to, so as such that actually we want to minimize the distance between like AB, like a sum of all these different pick up and drop actually, and the sum of like what happens if we just like deliver the packages just in one route basically, right? So I don't know if that's the questions.
Yeah, I mean that's just fascinating in itself, man. Thank you for sharing that. So a couple other questions here. We had a question coming here from Gretchen. Gretchen is curious about your data science team. How do you build your data science team? Is it full-time hires? Is it contractors, agency, a combination of the above?
Yeah, so that's a good question, right? So most of our, if not all of our data scientists are actually full time. And the reason of that, there is also actually one philosophy that we use as well at Gojek is that we want our data scientists, or in general, like analytic professional in the company, right? We want them to be as embedded as possible. And the reason for that is because we want them really to immerse themselves into the problem statement, right? That they face. So for that reasons, most of our data scientists or actually all of them um, are full time. The team is distributed among different cities. Actually, they're distributed across five different cities. So we have a team in Bangkok, we have a team in Vietnam, in Ho Chi Minh. We also have team in Singapore and in Bangalore, and then Gurgaon and in Jakarta as well. Right. So it's a very like a diverse distributed teams actually. Yeah.
And we got another question here about your team, which I think you kind of touched on already, but I'll have Fernando's question asked here. Fernando wants to know the dimensions of your team, how many teams, how many persons. So I guess we kind of got a sense of that with your previous answer, but anything else to add about the number of people or dimensions or?
Sure. Yeah. Thanks a lot for the questions. Right. So let me think actually, because like in data in total, we have around 100, people, right? Of which we have around 50 to 60 data scientists, probably a bit more now. That was like an old number, and it's also like increasing rapidly because it's just like a different pots, like has a, like typically it's also very dynamic, right? And we try to be as fungible as possible. But we have around 50 to 60 people, so each pod typically contains around 4 to 5 data scientists, depending on the complexity of the problems at hand, right? So we have a mix of like PhDs and masters in this case. We have around 11 nationalities. That's another dimensions that I can say. And then it's also like, if you look at the background, it's a very diverse team, right? So we have people who have studied econometrics, astrophysics, right? Me myself, I would consider myself pure mathematics. So in fact, I did some topology as my dissertations actually back then. And again, what can I say? Another, it's really like a multicultural team actually. I would say.
Yeah, that's pretty cool, man. That's really cool how you guys got that set up, and I think that diversity has allowed you to expand and grow into all these new markets. So that's really cool what you guys are doing. So I got another question here from Elke, my friend Elke. I connected with Elke during the networking session yesterday. Elke says, you mentioned having very patient and trusting executives. How do you communicate the status of a certain project or feature with them when you're still in the early R&D stage, and any planning and estimation of the work to be done when it's not clearly defined yet? That's an excellent question.
Yeah, excellent questions, right? Because to me that's really like the key, right? And this is also like the basically the job of senior leadership, typically in data science, right? To be able to sell the dream at first, because typically, like when you started to work on the certain problem, you don't know whether you're actually able to find the solutions or not, because a lot of problems that we basically work on, I would call it as a greenfield problem. So these are the problems which might not actually have a standard solutions out there. So we might need to try different approach until we get this solution, right? So definitely at first, it's really important to be able to kind of like sell the dream, estimate the impact, and really like communicate to the executive sponsor, like this is how we plan to do that, right? With the very clear milestones, and really bring the awareness to the companies that data science projects are very different than engineering projects, right? With data science projects, there are much more uncertainties compared to engineering projects. Typically, when engineering project, once you know the requirements, right, you can really estimate it very, to some sort of extent, in a very accurate way. But if you look at data science projects, we have a lot of dependencies to the data pipelines, and etc. So we also need to be able to kind of like educate the company that, hey, this is just the nature of the project itself, and really at the very beginning, kind of like set the expectation, right? And regarding that, the communicating the progress of the project itself, we have what's called MBR, actually, like a monthly business review. What's really nice about it, because the executives can actually just dial into the MBR, and MBRs are actually being delivered by the people who do the actual works, actually. So they have like a direct communications with the executives, because then we can go as details that we want. So it doesn't happen via intermediate layer. So we try to do is like we try to get the alignment. It's a very expensive meeting, because maybe there's like 40, 50 people in that meeting, but then under one call, we got a alignment in terms of progress and things that we need to do. And then we also want, using that cadence, we also want to empower a very fast decision making, right? Because, for example, if we cannot do experimentation in certain cities and we need to do it in other cities, then we have the head of the regions over there that can say, hey, okay, you can do this given ABCD, right? So that's how we communicate like a progress. And of course, our product managers, because what we try to do, especially for the big machine learning system, ML system, we always assign a product manager that manage, because it's basically like a product that we need to reiterate, right? Yeah. So yeah, exactly. So so product managers also are very active in communicating the progress to the executive, right? Yeah. So I hope that answered the question to a certain extent.
Yeah, I've got a follow-up question just myself on that, because I mean, with a company like yours, where you're actually, you're deploying models and you've got heavy on the research and experimentation within your data science teams themselves, do you have certain teams that are dedicated to just doing the research and certain teams that are dedicated to just executing, or are those teams integrated?
Yeah, those teams are actually integrated in the way, because again, like one principle that we want to really follow is that we want people to be as fungible as possible, right? And then what that means is that like people need to be able actually to do like end to end, from like a deploy models, like do prototyping research, even actually like write a query, right? In this case, like doing some simple dashboarding to monitor experimentation results, for example. So they're typically like a combined. So, but again, depending on the problems, right? For example, if we take a look at the KYC problem, facial recognition problem, we need a very specialized skill set. So we typically also have a very like a specialist people in the team. If we, for example, like what I mentioned earlier about voucher distributions, we use a lot of concept from causal inference, right? Then we have also like a expert in the team that actually are able to drive the research part of it. So it's a little bit of mix, I would say. For a bit more generic problem that requires a lot of engineering, then typically the team is also is comprised of like people with a very strong like engineering, right? So a little bit of that, but we try to kind of like mix them in a way. Yeah.
So that leads me to this next question from Juan. I think it fits in perfectly here. Talking about how to recruit talent, what's the key that you look for when hiring? Because you are definitely hiring a very diverse set of skills within data scientists themselves.
Yeah, thanks so much for the questions, right? So I think for us, what we really seek in the candidate is that we really look at problem solving skill set, actually, right? So for us, again, because the spectrum of problems that we deal with can be really like big, actually, right? So we really need the people who can really like exercise first principles. um, because again, like okay, of course, it's very good if they know like a different data science stacks, right? But again, like data science stacks can be very obsolete, right? Maybe in 3 months, the kind of like stack that we know now might be obsolete actually in 3 months. So um, we try to be agnostic, right? Which is why like our data scientists, they actually code in Clojure, in Java, in Python, in Go, for example, because depending really on like what kind of tools what will be the best tools in order to do the job. So that's what we try to do, right? So definitely like a problem solving skills. Second is that we also really go deep into the fundamentals. So it's not it's not only like and it's not only about like knowing the basic concept. It's also really like understanding the ins and outs, because in most cases we really need to do some certain tweaks into the basic concept, right? For example, taking a certain like evolutionary algorithm, for example, and apply it to do some kind of like a grid search or like Monte Carlo search in our problem, right? We need to be able to mix and match different like algorithm and really different techniques. And for us, it's just an apparatus actually that help us to really like solve the problem, right? So we don't want that to take away the focus on the problem itself.
Yeah.
So yeah, so those are the two qualities. Yeah.
I absolutely love that. So let's wrap it up with this final question. You mentioned first principles for somebody who is starting out as a data scientist, machine learning practitioner, whatever. If we were to distill down first principles for our field, what would those first principles be to you?
Yeah, so I think for me, I think there are a couple of, I would say, but I think my favorite will be is actually will is the ability to be able to decompose the problems into messy problem, right? So mutually exclusive problems where basically by tackling like each components of that, you can actually like tackle the whole problem, right? So sometimes it requires also some art in order to be able to compose that, right? By knowing like different concept and quantitative techniques, then it actually allows you to have a more freedom in order to decompose a problem. And also like that's definitely number one, right? And then number two really is to um, is like 5 level why questions. So don't stop asking only like one why. Always go to the root of it in order to be able to kind of like recommend the right solution for the problem itself, right? So yeah, those are definitely like two of my like first principles that yeah, I try to apply every time I face a certain problems, right, that I need to solve it using data science. Yeah.
Syafri, my friend, it has been an absolute honor to chat with you. Please let us do keep in touch and
Yes.
connect. Thank you so much for the presentation. I know it's probably like 1 a.m. for you out there in Jakarta, so you have a good night. I know you got a busy morning tomorrow. I can only imagine, my friend. Take care.
Okay, thank you. Thank you so much. Nice to see everyone. Cheers. Bye.